My name is Vicki Williams, and right now I'm going to do endo and exothermic reactions for you. This is going to be our first lab experiment. The first thing I'm going to do is show you another computer and how we work on the computer. We open the Logger Pro program, and this is going to be the program that's going to record our data for us. And we have to go to File, and we need to open. The reason I'm showing you this is because someday I hope that you will be doing these for yourself. I'm going to open the Chemistry with Veneer folder and open the first lab, Endo Exothermic reactions. Okay, so that's how we do that part. Let me show you the equipment we'll be using. I'll be using a LabQuest Mini. This hooks up to the computer so that it will read what the temperature probe says. There's a USB port, and then there's a port that hooks up to the LabQuest Mini right here. And then we plug this into the USB. Okay, and this is, a window is popping up telling me you don't have anything connected to this. So what I'm going to do is to connect a temperature probe. What happens with reactions is that some reactions will produce heat. And in that case, the water that is surrounding the reaction, because we're doing these reactions in a solution, will gain heat. And when the water gains heat, the temperature will rise. Now there's other reactions that actually take heat in from their surroundings. And in those reactions, the temperature of the water will actually decrease. A reaction where the temperature of the surroundings goes up is called exothermic, because the heat is leaving the reaction and going to the surroundings, which is the water that we're doing the reaction in. The opposite reaction, the opposite case, when the reaction actually requires energy to have the reaction reach a conclusion, is called endothermic. And we will see that by the temperature going down as the energy is taken from those water molecules and put into the reaction so that the two chemicals can react. Now I would like to take a minute and show you the equipment I'll be using. Goggles, safety goggles, the most important piece of equipment you could use in a lab. So the safety goggles fit over my glasses and prevent any chemicals from getting in my face. We're going to use a coffee cup sitting in a beaker to do the reactions in. This is what my temperature probe looks like. We're going to rinse that off. And the way we do that is we take a beaker and we label it wastewater, because you never want to put anything in a beaker without a label on it. And so I'm going to label this waste H2O. It's very expensive to get rid of unknown chemicals in a lab. So you always want to label even your wastewater so that somebody else, if you get interrupted, fire alarm, some reason, someone else doesn't have to come along and pay a lot of money to get rid of your water. So we're going to rinse the temperature probe with a bottle of distilled water. And that we'll clean it between the reactions we're doing. So the first reaction we're going to do is that we're going to take citric acid and we're going to take 30 milliliters of that. So that's right here on this line. I don't know if you can see that very well. I'll take a picture of it. And we're going to use 1.5 molar citric acid. And so you not only have to check the label to see what you're using, you have to check the concentration of it. 1.5 molar gives me the concentration of this. And I already washed my graduated cylinder and rinsed it with distilled water so that there's nothing in it that's going to mess up the reaction. So here we go. Now some people might want to wear gloves to do this. I know the things we're using in the lab today, and nothing needs to really have the gloves. Citric acid is the acid you find in vinegar. So, and pour that into the cup. Now, I'm going to weigh out my baking soda. And here's the scale. And let me show you the scale. Be back. Sorry, I'm adjusting the camera. Okay, so we put a weigh boat on the scale, and then we press 0 on it again so that we don't consider the weigh boat in the measurement. And then I'm going to put in 10 grams of baking soda. Let me show you this. It says solid sodium bicarbonate. And I'm going to put in some, let's see, we have 9.26 grams. I'm going to take a spatula and put in just enough to get to 10 grams. In front of the Logger Pro camera so you can see what's going on. I'm going to press collect, and I'm going to have it collect data for at least 30 seconds to get the baseline temperature. So we can see the temperature is right around 28.8. And that's been 30 seconds. Now I'm going to add the sodium bicarbonate, which foams immediately, and then I'm going to stir with the temperature probe, and we're going to watch. Oh, the temperature is dropping. So is this reaction exothermic or endothermic? That's what you need to think about. And it's still foaming a little bit. If you want to see how this foams at home, take a little bit of vinegar and a little bit of baking soda and put them together, and you will see the foaming action. And we can see the temperature continues to drop. And we're still going down. The mixture is still foaming. Okay, and it looks like our temperature curve is starting to flatten out. It's not decreasing as much. Still going down, but much, much slower. And we've reached our lowest temperature of 5.5 degrees Celsius. I believe that's going to be our lowest. And then it's starting to go back up. So at this time we can go ahead and press stop. And that is our first experiment. Citric acid and baking soda foaming away. And the temperature is dropping. And it's still foaming. The bubbles are carbon dioxide gas. And I'm stirring with the temperature probe. And we're still bubbling. You can do this for yourself at home by using vinegar or lemon juice and baking soda. So it's finally calming down. And the temperature is no longer rising.